Good morning, good afternoon, good evening. Welcome back to Chapter 2. We're talking about water. Water is the solvent of life. A solvent is usually a liquid. A solvent is a liquid that something else dissolves into. Imagine Kool-Aid. We've all made Kool-Aid. What do you need to make Kool-Aid? You need water and sugar in the Kool-Aid pack. You put the water and the sugar in the jug, and then you add the Kool-Aid pack, and you stir it all up. What happens to the Kool-Aid pack and the sugar? It dissolves into the water. Can you go in and pull the sugar and the Kool-Aid mix back out again? No. It is dissolved into the water. You can't remove it. Water is the solvent. The sugar and the Kool-Aid mix are the solutes. The solute is what dissolves into the solvent. When you do this, when you dissolve stuff into water, you have what's called an aqueous solution. Aqueous just means water. If water is specifically the solvent, then it's aqueous solution. So we're 75% water. Everything in us is dissolved in water, so your body is just a huge aqueous solution. Water is referred to as a universal solvent because of those hydrogen bonds. It's really good at dissolving those things. What doesn't mix with water? Oil and water don't mix. And the reason why oil and water don't mix is because to mix with water, you have to have positive and negative areas. Remember those hydrogen bonds that we talked about? Remember how we talked about that polar covalent bond? The polar covalent bond makes it so that water molecules have positive and negative areas. And if you don't have positive and negative areas like water does, then you can't mix with water. And fat, lipids, of which is oil, does not mix with water because it doesn't have positive and negative areas. Fats really are, this isn't exactly right, but fats are usually a lot of carbons and hydrogens attached to each other. And because there's a lot of carbons and hydrogens attached to each other, we talked about that, there's no positive and negatives here because this is a covalent bond. This is a covalent bond, no positive or negatives. To have positives and negatives, it has to be a polar covalent bond. So, sugar mixes with water. Does salt mix with water? Yeah, we call it salt water. It's called the ocean. Salt does mix with water because that bond, that ionic bond between sodium and chlorine is a positive and negative. The positive on sodium is attracted to the negative on chlorine, and that's what binds them together. Water actually, because it has positive and negatives, water is able to dissolve salt. This actually shows salt. Here is a glass of water with a pile of salt at the bottom of it. Here is a salt crystal. We've got the chlorines, which are negative, attached to the sodiums, which are positive. What the water actually does, remember on water, the hydrogens, the white ones, are positive. It surrounds the negative chlorine with a bunch of positive hydrogens. And it surrounds the positive nitrogens with a bunch of negative oxygens. The power of water, the amazing power of water, truly the amazing power of water, is that it is able to rip these bonds apart. It's able to separate the sodium from the chlorine. It's able to pull them apart. And water does that with a lot of stuff, actually. It's able to separate a lot of things. Anything that it dissolves is going to pull apart. So, acids, bases, and salts. An acid is a proton donor. A proton, we already talked about it. A proton is that thing in the center of the nucleus. The hydrogen atom. This is the hydrogen ion. A hydrogen atom has a proton orbited by an electron. right? This is a hydrogen atom. +1 and -1 gives me what charge? No charge. What has happened to this hydrogen? Because it has that little positive symbol next to it, it means that it has lost its electron. So if it's lost its electron, then this, the hydrogen ion, is just a little naked proton. That's all it is. Acids are proton donors, which means when I put acids in water, they liberate protons. What they actually liberate are these hydrogen ion things. An example of an acid is hydrochloric acid. Hydrochloric acid goes by another name, stomach acid. Hydrochloric acid is what gives vomit its distinctive flavor. When I take hydrochloric acid and I put it in some water, remember we said that water is really good at separating things? It'll actually separate the hydrogen from the chlorine. Chlorine will take hydrogen's electron with it. If hydrogen loses its electron, it becomes this thing called the hydrogen atom. This hydrogen ion. It becomes positive. Chlorine became negative because it took hydrogen's electron. This is an acid. It's called an acid because when you put it in water, it liberates hydrogen ions. It makes the essence of acidity. Hydrogen ions are the essence of acidity. If someone is really rich, it's because they have a lot of money. If something is really acidic, it's because it has a lot of hydrogen ions. Acids are proton donors. A donor means you give something. If someone donates to charity, it means you're giving something. Well, if you're donating something, that means somebody else has to receive it. Bases are proton acceptors. Sodium hydroxide, NaOH, is about as strong a base as hydrochloric acid is an acid. And if I put sodium hydroxide into water, water will do basically the same thing to it that it did to hydrochloric acid, the same thing that it does to salt. It will separate the two pieces. And in this case, the two pieces are the sodium and the hydroxide. The hydroxide ion says, fine, I'll go. But I'm taking sodium's extra electron with me. Poor sodium. Everyone steals sodium's electron. Because sodium lost an electron, it's positive. Because the hydroxide ion has gained an electron, it's negative. What would happen if I mixed equal amounts of hydrochloric acid and sodium hydroxide? It's going to explode! No. What will happen is the hydrogen ions will attach to the hydroxide ions and leave me with what? Sodium chloride. A salt. A salt is an equal mixture of acids and bases. Let's go back and finish up talking about a base. Sodium hydroxide. It is a proton acceptor. A proton acceptor means there's some part of this equation right here that says, please, please, please give me a positive charge. Remember, opposites attract. So what part of this equation down here says, please give me a positive charge? That negative hydroxide. And what's going to happen if I add a positive charge what's going to happen if I add the hydrogen ion to the hydroxide ion? What do the charges do? +1 and -1 cancel. That leaves me with what? HOH, which is just H2O. When you add a base to water, what happens is the base will suck up any naturally occurring hydrogen ions. Even in an ordinary glass of water, you've got uncountable trillions, uncountable bajillions of hydrogen ions floating in that glass of water. And when you add a base to the water, it will suck up the naturally occurring hydrogen ions and reduce them. When you add an acid, you add more hydrogen ions to them. The pH scale measures acidity. If I have a hydrogen ion concentration of 1 × 10 to the -7, what that means is, all right, first this is scientific notation. So how do we figure this out? Because it's negative, it means I start with a decimal point. And then I go back 7 places. 1, 2, 3, 4, 5, 6, 7. 1 × 10 to the -7 is tens, hundreds, thousands, 10,000s, 100,000s, millions, 10 million. It means I have a 1 in 10 million chance of finding a hydrogen ion in a glass of water. If I have a glass of water, it's going to be pH neutral. Neutral is 7. A pH of 7 means I have a hydrogen ion concentration of 1 × 10 to the -7. If I have that, that means if I had a pair of magic tweezers and I was able to go into my water and pull out water molecules one at a time, how many water molecules would I have to pull out before I found 1 hydrogen ion? And the answer is I'd have to pull out 10 million.